Then you have something called as cache aware access. Okay, yeah, you have cache memory and main memory. Again, hardware concepts, operating system concepts come into picture. Okay, cache memory is going to be very fast. It will have high speed, like your RAM. Writing IO operations, input output operations will be extremely fast when you do it on cache memory. Okay. However, this data will be limited, or this memory will be limited. So here within this, there is something called as cache aware prefetching. These are all research papers, friends. Okay, I've just made a note of all the research paper articles. Okay. So there is something called as cache aware prefetching. What your XG boost does is it's going to allocate a specific buffer wherein all of your gradient related statistics are kept. Now, what is a gradient? If you want to minimize your error, suppose the error is here, probably you have some parameters or some weights. You want to keep changing your weights to minimize your error. Gradient is also called as rate of change, or it is called as derivative, or it is also called as slope. So you reduce your gradient to minimize your error. So there'll be some values here when you reduce initial value and the new value. Those are called as gradient statistics. Again, when you update your weights, your gradient will change. Gradient will get minimized because the idea is to minimize your error. Now, again, you'll have the starting point, ending point, how the gradient is calculated. All those are gradient statistics. Again, you minimize. So since you want to do, probably your algorithm will go through multiple steps in order to minimize this and get to this minimum value. Since it's going to have multiple steps, there'll be huge number of gradient statistic values. And these values should be quickly retrieved. Why? Because immediately after first step, you have the second step ready there. So writing and reading these values, gradient values, should be very fast. As soon as this step is done, you move to the next step. As soon as this step is done, you move to the next step. So where do you want to save all these things? In some location from which you can fetch the data very fast and write it very fast. Okay. And if read write operations are very fast, then this gradient algorithm will run very fast. And the algorithm will complete faster, right? That is called as this cache aware prefetching. And when you have huge amount of data, supposedly you can go through this, a scalable tree boosting system. There is a white paper written called as scalable tree boosting system. There also, they have performed some experiments and they're saying that once again, it is 50 times faster than the other algorithms. 50 times faster, especially if you have huge number of rows in your data set, huge amount of data, millions and billions of records. 50 times faster means it will save huge amount of time, obviously. Yes. Yeah. Extreme gradient boosting can be used both for classification purpose and regression purpose. Then you have something called as block compression and block sharding. Block compression helps with whenever you have your hard disk read write operations, hard drive. Data, anyways, you're storing it in blocks. And you know the compression algorithms, right? You have zip files, RAR files, etc. What do? They compress the data. In that way, here also the data which is put in a specific block here is compressed. Okay, then. And what do you mean by sharding? Sharding means you place that specific block in multiple other locations. So that if this location or this hard drive is busy, you can access the data from some other location. That's called as sharding.